In class today we talked about histograms and how to create them, as well as ogives based on those histograms and their cumulative relative frequencies. So tonight we're going to finish up our discussion about histograms and kind of talk about histograms with uneven class widths. Alright, this frequency table is just another representation of the frequency tables and the histograms created from those that we looked at in class today. So this is the weights over here on this one, but this time instead of starting at 100, or instead of starting at 100 they started at 95, and they went in increments of 20 each time. So they've chosen to break it into 1, 2, 3, 4, 5, 6, 8 classes, and so the frequencies have changed for those classes and their relative frequencies have changed. And the next slide will show you the picture of that histogram. And you'll notice that this histogram looks pretty much identical to the two previous ones we saw in class today. And I showed you 3 representations to show you that there is no exact way to make a histogram. You try to make it the best that you can and get an even distribution of your data. There's several ways to do that, and they're not all exact. So we saw that a class width of 15, which we did in class, or a class width of 20, which you saw here and also in class, seem to both work well because the pictures of the histogram all tell you the same thing. The data is still skewed to the right, or positively skewed. And the bulk of the weight appears to be centered around 150 pounds, regardless of whether we use a class width of 15 or 20. So when you build your own histogram, you may not build yours exactly like the person sitting next to you, but they will be similar if you do them the best that you can. Also, you need to make note of that histograms don't represent every data point. Meaning, like when you have a dot plot, you have a dot that represents each data point that you have. When you have a stem and leaf plot, you have a number that represents each data point. In a histogram, each bar represents a portion of the data, but you can't pinpoint all the data values from that bar. You just know that those data values exist there. We've already talked about each of these shapes, but just to reiterate what we've already talked about. This first one here, unimodal, because it has one peak. Now, a unimodal distribution does not have to be symmetrical, as this one is. It can be negatively skewed, because that has one peak, or it could be positively skewed. It just has to have one peak to be unimodal. Bimodal has to have 2 peaks, and yes, it can be symmetrical. Not often, but it can be. And we most often see that again when we've taken data from 2 different genders and put it on the same distribution. Multimodal is more than 2 peaks. And then down here we have our skewness. Skewed negatively, remember that's when I drew the feet that were really good. I was quite the artist. But also that's called left skewed. Symmetrical, which doesn't have to necessarily be unimodal. We can have other graphs that are symmetrical. And then a positive or right skew. And there's the feet for you, because I know you like my drawings. There was one other shape that we talked about, which was uniform. So here's a picture of that. It most often looks like a rectangle. This histogram is going to begin our conclusion of our talk on histograms, and it has to deal with the ages. And each class has a width of 2. Now notice it is a bit choppy. We have gaps here and here. It is very much skewed to the right. And sometimes frequency distributions are created with the unequal class widths so that we can get rid of these gaps, because we'd rather have a nice, more even flowing histogram. And so I'm going to show you that next. So here's the frequency distribution, and we start off still with class widths of 2 all the way until we get to this class. And this class becomes a class width of 12, this one becomes a class width of 10. And hopefully that's going to help eliminate the gaps that we saw in the previous slide in that histogram. Now our frequency is still high in the first three categories, in those age ranges, but we have at least one frequency in each of the following classes, which is what we're trying to get. So now here's that histogram created, and you'll notice that although all our bars are touching as we want to in a histogram, that it seems that it is quite a distorted picture. Okay, notice that it appears that there are a lot of people over 28 in these in this class, when in fact there really are not. This larger rectangle higher up than it gives the appearance that there are more people than there really are represented in those bars. And so when that happens, there's a way that we can make it look a lot nicer for our purposes. So in order to correct this distortion, we create what's called a density histogram. The vertical scale is called density, so instead of frequency or relative frequency, our vertical scale will be the density. And the density of a class is calculated by doing this. You take the relative frequency and you divide it by the class width. And so this choice for density makes the area of the rectangle equal to the relative frequency, which is going to make it not as tall and be much more representative of what we're trying to look for. So here's our frequency table again, and we've added the column on density. And so to get that density column, we take the relative frequency and divide it by the class width. So again, we've got our class widths here, 2, 2, 2, 2, 2, all the way to here is 12 and 10. And now I need to take the relative frequency and divide by that number. So here's that showing you that step, and this number should equal my density over here. Now recall that if I were to take the sum of these, that would equal the total number of data values that I've taken, however many people I've got the age for. Relative frequency should equal 1 or extremely close to 1. The density, however, is not going to equal any number in particular. So now we have the resulting histogram, and you'll notice that here our representation of those class widths or bins is very much more put in perspective than on the previous histogram we had without the density calculations. And you'll notice that instead of relative frequency or frequency, we have density listed here. And so this offers us a more reasonable representation of the data, as well as a better perspective. And this might be important for people that are maybe going into marketing and are trying to market a product and they want a better representation of the graph that they're presenting, or even doing a presentation for your own company within a boardroom or board directors. You would want your graphs to be representative of what you're trying to get across to whatever group you're talking to. And if at this time, if you would please turn your notes over to the back side and write the number 4 in the lower left hand corner. Thank you.